Hey, it's Nono, and this is the Getting Simple podcast.
So, Nono, a lot of times when I'm starting a new project and I know it's going to involve a new workflow that I haven't touched before, I call you up and I take your advice because I know you've probably done it. And the last time this happened wasn't too long ago. It was about a month. And the conversation we had then was on StyleGAN. So do you want to tell us what StyleGAN is?
Yeah, I would start saying StyleGAN is a machine learning algorithm. If you know terms like pix-to-pix or GANs or generative adversarial networks or generative programs or things that generate synthetic images, you're on the right track. StyleGAN, to put a frame of reference, is an algorithm that was open sourced by NVIDIA. That's the company that creates the graphic cards, and is a program that can learn from the features or style, that's where the name comes from the style of a bunch of images, so a big folder with images, and try to generate synthetic or fake images that resemble the original ones. The biggest experiment that has been conducted here is grabbing hundreds of thousands of publicly available images from Flickr, create a dataset, which is a folder with photographies of faces, and train StyleGAN to be able to generate new faces.
Right. So, but it's an adversarial network. So where is it competing? What two networks are competing?
Right. So the adversarial part comes from generative adversarial networks. And there was a researcher called Ian Goodfellow that in 2014 came out with a new machine learning network architecture, right? So when I say architecture, it means the composition or the different parts that form the actual program, the computer program. Normally on image classification tasks that, you give it an image and it tells you if it's a cat or a dog, for instance, or object detection where the program will tell you where each of the objects is on an image. The programs were, they had like a series of layers, they're called in the network. But in these GANs or generative adversarial networks, there are like two blocks. One that is called the generator that learns how to generate images, and then a discriminator that is the one that learns to differentiate if an image is real or if it's a fake, right? If it's synthetically generated. And what really succeeded in this sort of architecture was that the generator was trying to learn how to generate images as the discriminator was learning how to differentiate if they were fake or not. Each piece of the network, both the generator and the discriminator, get better and better and better until the network knows almost perfectly how to generate new images that we as humans cannot discern from the original ones.
So it's like an endless game of the unstoppable force meeting the immovable object, basically, and both are getting more unstoppable and more immovable.
Exactly.
So it's a fun game, yeah.
And, I kind of got introduced to this world through a network that was developed, I think, in 2015 or 2016 by Stanford researchers, Philip Isola and his team. And this network was called pix-to-pix, or is called pix-to-pix, has been a really, really viral network that showed up in many, many different projects. I've used it in many projects myself. And it's one of the first ones, or I would say the first one that got to be known by people outside of the field of machine learning.
Yeah, so it's really interesting what these models are capable of and the kind of amazing and high quality image that they produce. But there's also this unexpected outcome of this process. And to me, that's the latent space, which is basically a kind of high dimension vector space. But looking at that and pulling every vector, which corresponds to an image, what we find is that it becomes a catalog of all the types of images that you fed it. So if you were training a StyleGAN model on flowers, then the latent space will catalog every single type of flower that was in the original data set, but recreated and tweaked and imagined in a new way.
Yeah, right. You've touched into two different topics that our audience might not be familiar with. One of them is the unexpectedness, and the second one is the latent space. The first one, the unexpectedness, has to do with us not knowing what a program is going to output after we give it an input. If you have a simple function that is like a linear equation or like an add to function where you just provide a function with a number a and b and then the result is a plus b, then the result is deterministic. We know, and if you know math, you can determine, any system can determine what the result is going to be. But undeterministic programs, and this is something that is present in machine learning networks, when you provide the network with an input, it's really hard to guess the output. And by varying the input slightly, you might get results that are unexpected or undeterministic, right? So we cannot know what the network is going to spit out.
I mean, does the network even know what it's drawing? If I train it on images of buildings, does it know that it's drawing a building?
No. So there is a nuance or like something that is a difference between the pix-to-pix algorithm and StyleGAN. Pix-to-pix is something that is called supervised learning. So you actually have to provide it with pairs of images. So you can have to say, okay, I give you this outline of a face, and I want you to produce this texture or those colors for the face. Or I give you this outline of a flower, and I want you to fill in the colors of the flower or some texture. But in StyleGAN, the process is a bit different. We have something that is called unsupervised learning. We just provide the algorithm with a folder with tons of images, and then it extracts different parameters. And what you mentioned before, right? The input vector is, or what this program gets as an input, is a series of floating numbers. Actually, 512. It's like a tensor or like a 512 linear parameter, and it can vary from, I think, every component of this 512 component vector can range from -1 to 1. And depending on what you give the network, it will spit out a different solution. And what's fascinating is that StyleGAN actually maps out some of those combinations of parameters to facial features. So when you train it with thousands of faces, changing specific parameters in that vector will make the person look blonde or brunette or red-haired, or maybe have a mustache or not, or have like blue eyes or like green eyes, right? So that's fascinating. And this is not only something that can happen with faces, but with many, many other things. Like you could train it maybe with cars, and it might learn that specific parameters can be mapped to the size of the wheels or the size of the windshield or things like this. What Aziz was referring to as the latent space, right? In this unsupervised learning, when we get like thousands of images, what the network tries to do is to organize all the knowledge that it has acquired from those images into a map of things, or like a vector space that have 512 dimensions, in which it can make sense of each of those features. So there might be one dimension that has to do with the color of the eye, and another dimension that has to do with the size of the mouth or the ears or something like that. You know, and one of the important things to note, like in a more high-level comment about StyleGAN, is the repercussion in our culture for these type of algorithms. They're going not to only let us generate images and, you know, for fun, but they will allow us to hijack the process that many artists or content creatives were doing. So we can now generate fake images or new images that resemble, I don't know, illustrations. Think about, for example, the New Yorker illustrations. You could feed this network with a ton of those, and you might get results that look alike, some of them, but they're not really any of them. And these, in terms of art, are really controversial networks, because if you have a really characteristic style, you might give like hundreds of paintings of some famous artist, and this network might replicate new combinations. And what's fascinating to me is that, you know, it gives us the opportunity to hallucinate or imagine different combinations of things that already exist, but also are a creative medium. So we can actually use this tool to create in the same way that we have created other things of that, or that somebody else has created things. What do you think, Aziz? What do you think this?
Yeah, I mean, it sounds like a great remedy for like creative block, right? Like if you're stuck creatively, then just put all your work into a StyleGAN model, and there you go.
The problem that I got asked by some people at MIT while I was working with Pix2Pix was, is it actually teaching you or letting you imagine in different ways, or is it doing the work for you? And, when you put the machine at work and maybe, let's say, it's feeling the texture of a flower or if generating new paintings, you don't have to go through the process of thinking about how to, get the canvas or like put the colors, choose the colors or things like that, or like think about shading or things like this. So there is also this problem of, do we learn less because we can skip certain steps? Or even, do we skip the process of hiring a designer if we have a computer algorithm that can generate those paintings for us, for instance?
I mean, there's a lot of work in AI that's headed in that direction, and I'm sure we'll have more of these conversations going forward on Bytes. So this conversation was on StyleGAN, and thank you guys for listening. We'll see you on the next episode.
Thank you, everyone. We'll see you next time.